greetings to one and all. In today's session, we will be learning about the Udemy course on computer organization and architecture. So it covers 5 lectures, in which the first lecture it tells about the different types of number systems, namely binary, octal, hexadecimal and the decimal conversions, and how the conversions interrelate each other, and also about the different types of logic gates, which includes the basic gates such as your AND gate, OR gate or NOT gate, and how various circuits can be realized using your basic gates, and also about your universal gates. Universal gates are nothing but your NAND and NOR gates, where all the basic gates can be realized using these NAND and NOR gates, so they are called as universal gates. Then moving on to the binary to the gray code, what is the procedure? And this gray code is a single bit change code, whereas your binary code is a sequential code. Then we'll move on to the what is the procedure for your BCD additions. So in the second lecture, we will be covering the basic operational and the functional units of a computer, and also about the bus structure, the different types, okay, either the single bus, double bus or the multiple bus structure, what is available for the transfer of data and address in the inside the computer for executing the instructions. Later, moving on to your memory hierarchy, where we learn about your big Indian and a small Indian method of memory addressing. So wherein the programmers will be enabled, or the students at the end of the course will be enabled how to write the efficient codes. That moving on to the lecture 3, so which relies on your instruction, the complete set of instructions. What are the 3 points? Okay, the data has to be fetched, decoded, and it has to be executed. So, and the instructions, how it has to be sequenced to carry out a single process. For example, if I want to add 2 numbers, and then moving on to the addressing modes, how the data has to be addressed. Okay, so whether you can follow the simple general direct addressing mode, move A comma B, the data of register B will be moved to A, or we have to adopt the register addressing or register indirect addressing, or we have to go in for a complement, that is implied addressing. Example is your CMA, complement the accumulator. By the word itself, it is implied the function, right? Then when you move on to the design of the ALU, when we are going to comprehend the design of the ALU, what are the process that is going to take place inside your arithmetic logic unit? Either it is going to be addition process or a subtraction process, or what are the gates that is going to be involved to give this particular operation. Okay, whether I am going to realize a half adder or design a full subtractor, or I am going to use how to implement the 2 full half adders using a full adder, or how a same circuit can be used to implement a parallel adder bar a subtractor just by using a NOT gate or by using an XOR gate. Now moving on to your unit 5, where we will be understanding the methodologies which is used for the fast multiplication and division in a computer, because computer performs at a very fast and higher speed with higher accuracy. So for this, inside the computer, what are the different processes that is taking place? It can be either a bit pair recoded Booth algorithm, or the fast save addition of summands, or we have to go in for a restoring division or a non-restoring division depending upon its applications. So these calculations will enable the learners in the computing systems to aid for the various challenges in the advanced technical domain. I hope all are ready to learn with me this computer organization and architecture. Thank you, students. A very happy learning.